Good morning. Welcome to our revision lesson. We're dealing with the April 2021 final exam. Let's start. So, the first question is limits. Determine each of the following limits. So, we have the limit as x approaches infinity. Then you have x. This is multiplied by ln of 1 plus 3 over x. Right, let's see what happens. You can't use your calculator, so you have to know what happens as x approaches infinity. Okay, now, first thing to do is substitute. Right, so let's substitute, and then let's see, just check the results. What do we get? So if we substitute here, that is infinity. Then I have ln of 1 plus 3 over x. Sorry, that's going to be 3 over infinity. Right, so we substitute infinity. Now, okay, let's see what happens here. Right, so now we need to know that, remember, as we are approaching infinity, if you are dividing, if as your denominator approaches infinity, if you remember your rules, if I have a constant, whether it's a positive or a negative, and you divide by a very, very large number, you approach 0. Okay? When you are dividing by a very, very large number, like infinity, you are approaching 0. So therefore, 3 divided by infinity. So now what do I have here? I have infinity, then I got ln of 1 plus a constant divided by infinity, 0. Right. Now, here we got infinity, then I got ln of 1 plus 0, which is 1. So now, ln of 1, log of 1 is 0. Alright, now, 0 times any real number that we know of, whether it's positive, whether it's negative, it's 0. Infinity is something that we do not know how the value of infinity. Okay, so 0 times infinity is indeterminate. Right, so that is indeterminate. Okay, so 0 times any real number, like 0 times 2, 0 times 1 million, that's 0. But we do not know infinity, so we cannot determine what is 0 times infinity. Yes.
What if I made it a fraction?
That's exactly what we're going to be doing. That's exactly what we're going to be doing. Right, so that is indeterminate, so what do? We need to rearrange it into a fraction and then use L'Hospital's rule, L'Hopital's rule. Right, so now this is equal to the limits as x approaches infinity. So we want to rewrite this in the form f of x all divided by g of x in order for us to use the rule. Okay, so we will rewrite this as a fraction. So it's easier to take x to the bottom than rather to take ln to the bottom. Okay, so we got ln of 1 plus 3 over x. And if I take, this is x to the power 1 at the moment. So when I take it to the bottom, it becomes x to the power minus 1. You know, see that? So we always rewrite it as a fraction. And now we apply the rule. Differentiate the numerator, differentiate the denominator, and then simplify and then resubstitute. Let me give you 2 minutes to just do that. You know what's the derivative here. Let me refresh your memory. If y is equal to k ln f of x, then dy over dx, you should know at this stage that your derivatives off by heart. So this is going to be k times f prime x all divided by f of x. That is a formula to differentiate ln. So let's do that quickly. Alright, so we rewrote it as a fraction. So now we differentiate the numerator, differentiate the denominator separately. Right, so this is equal to, you always got equals to first, then you copy down the limits as x approaches infinity, differentiate the numerator. Now, your f of x here is 1 plus 3 over x. So that 1 plus 3 over x is actually 1 plus 3x to the power minus 1. You're clear with that? So when I differentiate it, the derivative of 1 will be 0. The derivative of 3x to the power minus 1 is going to be minus 3x to the power minus 2. All divided by, differentiate the denominator, the derivative of x to the power minus 1 is going to be minus 1x to the power minus 2. Okay. Yes.
Not f of x.
Oh, sorry, my mistake. My mistake. Right, so f prime x divided by f of x. So that's minus 3x to the power minus 2. I forgot about f of x. So my f of x there is 1 plus 3 over x. Yeah. So now my f prime x divided by f of x. So that's differentiating the numerator, all divided by, differentiates the denominator, which is going to be minus x to the power minus 2. So what did we do here? We found first derivative of the numerator, first derivative of the denominator, and this is the rule that we use. Right, so now what do we do? After differentiating, we try and simplify as far as possible. So what can be simplified? Okay, this is 4 marks, I can see. So we'll have to simplify, yeah? So this is equal to, now I don't want to be copying down, I'm going to do the simplification here. That is, I'll keep on copying down the limits as x approaches 0. So let's do the simplification here. So this is simplification. So I've got minus 3x to the power minus 2, all divided by 1 plus 3 over x, all divided by minus x to the power minus 2. Right, so this is what we have. Let's simplify as far as possible. Right, so now, here, my numerator is minus 3 over x squared. You can see that? So minus 3x to the power minus 2 is the same as minus 3 all divided by x squared. I'm making my exponent positive here, and this is 1 plus 3 over x. So this is the top, and minus x to the power minus 2 is the same as minus 1 over x squared. So what I'm doing now, I'm just rewriting them with positive exponents. Now I have a fraction divided by a fraction here. Can you see that? It's a fraction divided by a fraction. So what do I have now? I have minus 3 over x squared on the top, all divided by 1 plus 3 over x. I could have found an LCD here also, but I'm just noticing that there's an x squared here, there's an x squared there, so the question is it necessary to find it? We will see now. Okay, we will see. So now there's my top fraction, there's it here, this division sign. Okay, this division sign here, I'm going to change it to multiplication. Okay, so this is the whole thing here, there's my division changing to multiplication, and this can be written as minus x squared over 1. What happens now? Can you see what happens here? So this x squared and x squared will cancel now. So now, let's write down what remains here. Right, so this is equal to the limit as x approaches infinity. Now, what happens here? Okay. So that x squared and that x squared cancelled. So that and that cancel. Negative 3 times negative 1 is going to be a 3. 3 over 1 is just 3. So on the top it's just 3. The bottom is 1 plus 3 over x. You're clear with that? Right, now, so we applied the rule first time. Now, simplify and now substitute. So let's substitute again. So that's going to be 3 all divided by 1 plus 3 divided by, we are replacing x with infinity. Alright, so now let's see what happens here. So that's 3 all divided by 1 plus, when you divide by infinity, it's equal to 0. So therefore, 3 divided by 1 plus 0 is 1, and 3 divided by 1 is 3. Right, so this was not so simple because of the simplification that's required. This is 1.1.1. Let's move on to the next question. Right, let's not waste time. Here's the next one. So the next one is 2 marks only. The limit as x approaches, or x tends to 7. Let's see what happens. Step number 1 is substitute, and let's see if we get an answer. So if I substitute here, this is going to be, we got 1 over 7 minus 1 over 7, and in the denominator you got 7 minus 7. So anything subtract itself is 0. 7 minus 7, 0. So it's 0 over 0. This is indeterminate form. So what do we do? Differentiate the numerator, differentiate the denominator. So this is equal to the limit as x approaches 7. When I differentiate the top, remember, minus 1 over x is actually minus x to the power minus 1. Obviously you know that. So when I differentiate 1 over 7, I'm getting 0. When I differentiate minus x to the power minus 1, it's going to be minus times a minus, which is a plus. X minus 1 is minus 2. You're clear with that? Simple. Now, that is differentiating the numerator. Differentiate the denominator. The derivative of x is 1. Derivative of minus 7, 0. So you indicate what happened here is you found f prime x all over g prime. That is what you did there. So what do we do now? Simplify and then resubstitute. So this is equal to the limit as x approaches 7. So x to the power minus 2 is 1 over x squared. All divided by 1 is still 1 over x squared. Right. So this is simplified. Now substitute. That's going to be 1 over 7 squared, which is going to be 1 over 49. That's all. Yes.
So whatever I didn't differentiate, but I simplified and substituted that thing.
Yes, you can do it that way. Alright, so the question is, if you did not use L'Hospital's rule, so they did not specify. Right, so what happens if you decided to do it like how you did it in grade 12? So let's see what happens. Alright, so now O 1.1.2, we got the limit as x approaches 7. Alright, so now we already know that it's 0 over 0. Let's assume that we already checked it first. If we go and simplify. So what do I mean here? I'm going to find the LCD here. I'm going to find the LCD. My LCD there is going to be 7x. So I'm going to be multiplying 1 by x and this minus 1 by 7, which is minus 7. So there's my top fraction, all divided by x minus 7. So this is LCD. That's what I did. I found an LCD of 7. So now I can simplify this further. So now again we have a fraction divided by a fraction. You can see there's a lot of fractions involved here. So I've got x minus 7 all divided by 7x, and then this division sign will change to multiplication. And remember, this is x minus 7 all divided by 1 as it stands there. When that division changes to multiplication, then it will become 1 over x minus 7. So what happens now? You can see that x minus 7 and x minus 7 will cancel. So I end up with just 1 over 7x simplified, which is equal to 1 over 7 times 7, which is equal to 1 over 49. So this is simplifying, using our LCD technique here. And this is the method that we learn now. So it's up to you, it's your choice. Right, so the next one, 1.2.1, this one is 2 marks, log y. So what are we given? Minus log y, just double check me, I got the questions, eh? So there's minus log y is equal to the limit as x approaches 0. We got sine of 7x all divided by x. Okay, now determine just log y. Let me just make sure everything is correct. So that's minus log y is equal to the limit as x approaches 0, sine of 7x over x. So step number 1 is let's substitute. Alright, so this is the question. Let's answer it now. So 1.2.1. So we got minus log y is equal to the limit as x approaches 0, sine 7x all divided by x. So what do we do? Step number 1 is substitute. So when I substitute, this is going to be sine of 7 times 0, which is 0, and this is 0. So sine of 0 is 0, and then you got 0 over 0. So it's indeterminate form again. You can see that. So let's write this down. So what do we do? Differentiate the numerator, differentiate the denominator. So now I've got minus log y is equal to the limits as x approaches 0. Differentiate sine 7x. The derivative of sine 7x is going to be cos 7x times the derivative of 7x, which is 7, all divided by the derivative of x, which is 1. So what did we do? We found the first derivative of the numerator, first derivative of the denominator. What do we do? Simplify. Well, there's nothing much to simplify. Right, let's go and substitute straight. So that's going to be minus log y is equal to, I'm going to go 7 cos of 7 times 0. Cos of 0 is 1. 1 times 7 is 7. When you do your substitute. You're clear with that? So the question is find log y, not find minus log y. We were given minus log y. So now I have an equation. Now you can see that there's no more limits here. It's just an equation. So all I can do is just divide. Simple. So that's going to be log y is equal to 7 divided by minus 1, which is equal to minus 7. And here's your 2 marks. And you know that whenever they give you a log function, they don't end here. we normally need to solve for y. So that is the next question. So the next question is find y. This is what we want to work on for 1 mark. Right. So how do we answer this question? So from 1.2.1, this is how you need to answer a question that's where you're taking information from the previous question, you see? To show now where did you get this? So I'm saying from 1.2.1 log of y is equal to -7. Okay. So now we need to solve for y. So we need to know our laws, which you already obviously know. So your log law is if log a to the base b is equal to c. This is a log equation. We must convert from log form to exponential form. So now a is going to equal to b to the power c. The base in the log equation is still the base, but it will become the base in the exponential equation. That's how you remember this. So if your base is not shown for logs, what is the base? The base is 10. Right. If it was natural log, then the base is e. Remember this. I don't make a mistake there. So your base here is 10, so your b is 10. So therefore, y is equal to 10 to the power -7, which is equal to 1 over 10 to the power 7. Okay. Which is 1 over 1 and 1, 2, 3, 4, 5. 6, 7. Correct. And round this up. Round it up. What do we get?
1 times 10 is 27.
Yeah. Or you can just leave it like this. Just leave it. You don't have to worry. The main thing is you worked out the value of y. That is your 1 mark. Our next question, 2 marks. Determine the values of x for which f of x is discontinuous. Okay, so if you have a fraction, if you have something like f of x divided by g of x, let me not use f because you see f in my, let's say this is p of x divided by q of x. So this fraction will be discontinuous. So it will be discontinuous when the denominator, it's discontinuous where the denominator is equal to 0, because you cannot divide by 0. Okay, it's undefined. So what we're going to do is we will take the denominator, make it equal to 0, and find out what are the values of x that result in this denominator being 0. Right, so let's see. So for discontinuity, e to the power x minus 2 e to the power 1 minus x is equal to 0. So now we need to solve for x, and we have to remember our n3 work here. Okay, we have to remember our n3 work, our exponents. So let's see how we're going to deal with this one. Alright, so now I've got e to the power x minus 2 e to the power 1 minus x is equal to 0. So I can write this as e to the power x minus 2 times e to the power 1 times e to the power minus x is equal to 0. I'm splitting up my bases, my exponents. Okay, so now this is e to the power x minus 2 e to the power 1 all divided by e to the power x. equals to 0. You'll see that? Now, okay. So now, from here, you can use a substitution if you want to. Or you can just do it as it is. Let me just do it as it is here. Okay. Now, what I'm going to do is, I'm going to multiply. Okay, I want to get rid of this e to the power x in the denominator. So I'm going to multiply by e to the power x on both sides. Okay. And we know that e to the power x cannot equal to 0. So now if I multiply by e to the power x here, let's see what happens. Alright, so I've got e to the power x times e to the power x. If you want to use a substitution, if you remember the examples that we should do before, we can also use a substitution. So, but basically, if I multiply e to the power x times e to the power x, it's e to the power x all squared. Okay. Right, so minus 2e times e to the power x. Sorry, my mistake there. Minus 2e. Because remember, e to the power x and e to the power x will cancel here, so I end up with just minus 2e to the power 1. And 0 times anything? 0. Okay. Now, let's see what happens here. Alright, so here, I'm solving for x, so let me isolate this term here. So this will be e to the power x all squared is equal to 2e to the power 1. Right, now, we have a square. We have a square. An example is if I got k squared is equal to 4. The same concept. If I have a square, what do? You find the square root of both sides. So I'm going to go k is equal to plus or minus the square root of 4. That means k is equal to 2 or k is equal to minus 2. There are two possibilities. Okay, because 2 squared is 4, minus 2 squared is also 4. Right. So that means there are two possibilities here too. Right, so now that's going to be e to the power x is equal to plus or minus the square root of 2e to the power 1. Right, now, okay, so now e to the power x is equal to the positive square root of 2e, or e to the power x is equal to minus the square root of 2e. But now, we know that e to the power x cannot equal to a negative. Okay, so if we go back to our M3 one, I'm not going to get too deep into that, but the fact is your exponential graph. Okay, let me just show you what I'm talking about. So, e to the power x, this is your exponential graph, y is equal to e to the power x, and this graph, it comes very close to 0. It doesn't touch 0, it never ever goes down to the negative. Right, so your exponential graph can never equal to a negative, so x must not equal to minus, or you can say not applicable. Right, so this does not work. So the only equation that we are working with is this one. Right, now, so here, let me just do the working out here. Right, so I'm working with this equation, e to the power x is equal to the square root of 2e. Okay, the reason here is e to the power x is always greater than 0. That means your graph is always positive. Now, that's the reason. So going back here, all I need to do is solve for x. Okay, So x is the exponent. Okay, x is the exponent, but the bases are not the same. So if the bases are not the same, then you introduce logs on both sides. But in this case, we are introducing natural logs because we know that ln of e is equal to 1. So I'm going to go. Or you can do this here. If you understand, in one step, you can convert from exponential form to log form. But I prefer to do it by introducing ln on both sides. So that's easy to remember. So you go ln of e to the power x is equal to ln of the square root of 2e. And now I can bring down this x value there, so that's going to be x ln e is equal to ln square root 2e. So I got x is equal to ln of the square root of 2e, all divided by ln e. We know that ln e is 1. Now let's work it out on a calculator here. So I'm just working out ln square root 2e divided by 1. Give me this calculator. Right, so let's see what we get here. So to get ln, what do we have here? X is equal to ln square root 2e. So that's ln square root of 2e. To get e on the calculator, you press shift ln and you press 1. So it gives you e to the power 1. Then I get 0, comma 8, 4, 6, 5, 7, 3, 5, 9, 0, 3, which is equal to 0, comma 8, 4, 7. Now, let's check. There's a lot of working out here. Let's make sure. Let's see if this is correct. So let me just store this in memory. I'm using my memory function. You have to learn. There's many memory functions. A, B, C, D, E, F, X, Y. And let's test it out. So that's e to the power. And we get 0. So it works perfectly. Alright, so we're moving on straight to 2.2. 2.1 is the first principles example, which is simple, using the binomial theorem, which is given to you on the formula sheet, where you can see that is too simple for me to do on the board. Alright, so let's go. Let's continue with the differentiation. Right, so now calculate dy over dx of the following by using the derivatives of sin x and cos x, but you don't see sin x and cos x at the moment. Alright, but they say you need to use the derivatives of sin and cos, as well as the rules of differentiation. Now, they gave you a hint, but I'm going to write it down. So the hint, what you need to do here is you need to remember the log law. You don't use it much in N3. But when you come to N6, this is the law that you're going to be using under differential equations, but it is a log law. So let me just write that down. So if I have e to the power ln x, e to the power ln x, what is it equal to? Now, you know the base, if your base is not shown, your base is e. So if the base of this exponential equation and the base of that log, which is part of the exponent, if those two are equal, then the answer is always x. What do I mean? If I have e to the power ln of 2, so what is x now? 2, you can test this out on your calculator. E to the power ln 2 will equal to 2. E to the power ln of 1, 2, 3, 4, 5 will equal to 1, 2, 3, 4, 5. So in general, e to the power ln f of x will always equal to f of x. This is the rule. Okay, that you need to know here. E to the power ln of whatever this is will equal to the same thing. So in this case, we have e to the power ln of f of x. It's step number 1. We need to apply this log. So my f of x here is tan. So this is equal to just tan. Right, so that was the first thing. Now, obviously, you know what to do. We need to use the derivatives of sine and cos. So we need to rewrite tan. So tan x can be written as sine x all over cos x. And then from here, simple. You know what to do. It is the quotient rule. Okay, we're going to be using the quotient rule. So the quotient rule is, let me write down a bit. We're going to go dy over dx. So what are we doing? We are going to be using the quotient rule. So the quotient rule works like this. You copy the denominator. Now you start by copying the denominator. So you copy the denominator, differentiate the numerator and multiply it by whatever you have. Differentiate the numerator. Derivative of sine x is cos x. Then put a minus sign. So you copy the denominator, differentiate the numerator, minus copy the numerator, which is sine x. Differentiate the denominator, the derivative of cos now is minus sine x, all divided by the denominator squared. Quotient rule. Don't go and mix up the quotient rule. Okay. Now, let's simplify. So my dy over dx. So I got cos times cos, which is equal to cos squared. Then I got a negative times a negative, which is a positive. Sine times sine will equal to sine squared, all divided by cos squared. So now, obviously, I don't think there's anyone that doesn't know this. Cos squared plus sine squared, your square identity. If only if the angles are the same, cos squared plus sine squared is equal to 1. So I got my 1 over cos squared, and 1 over cos is sec. So 1 over cos squared will be sec squared, and that's basically it. Or if you did not use your square identity here, you could have separated it into two fractions. This can be written as cos squared over cos squared plus sine squared all over cos squared. So you could have went in using this method here. So anything divided by itself is 1. Sine squared over cos squared is tan squared, and from your square identity, 1 plus tan squared is equal to sec squared. It's up to you, whichever way you want to do it. Let's move on. Alright, so 2.3.1, determine dy over dx. Simplification is not required. So now we're differentiating. So what are we dealing with? Term 1. And let's see term 2. So term 1, y is equal to k ln f of x. Term 2, y is equal to k times inverse tan f of x. Right, so then we know now what is the derivatives here. So your derivative here, dy over dx, well, you know, this one we've just used it under first, limits, remember? So this is going to be f prime x all divided by f of x. So we know this part here when we're dealing with that. Then when we come to this part here, inverse tan, so your dy over dx, your k is just a constant. This is going to be f prime x all divided by 1 plus f of x all squared. Right, so that is, this is differentiation of inverse trig functions. Okay, now, but how does this problem begin? It is in the form k f of x to the power n. When you read it, that's the first thing that you must see, or you must realize that it's in the form f of x to the power n. That means you have a power which is a number. So what rule do you use? You use the chain rule. So now y prime, this is going to be k f of x to the power n minus 1 times the derivative of f of x, which is f prime x, and this is the chain rule. So now we got everything there. Let's differentiate. I'm going to go dy over dx. So we start with the exponents multiplied by the coefficient here. So that's going to be 1 times 10, which is 10. So there's it here. So this was, that was k multiplied by n, and then there's it here. 1 times 10, which is 10. Then I got my ln of x squared plus 1 minus inverse tan of 6x. So I'm at this stage here now. And then all I do is n minus 1, 10 minus 1 is 9. That's your 1 mark already. Okay. Times, now I'm here, times. So times, now I need to differentiate ln of x squared plus 1. How do I differentiate ln of x squared plus 1? You know that this table, obviously you must have it in your head, the table of derivatives. So the derivative here of x squared plus 1, that's going to be 2x plus 0, which is f prime x all over f of x, which is x squared plus 1. So that's done. Minus, now we are differentiating inverse tan of 6x. So that's inverse tan of f of x. So the formula is f prime x. So there's my 6x here. F prime x is 6, all divided by 1 plus f of x all squared. So 6x all squared will be 36 x squared, and you're done. Simple. You can say that. But only if you know the formulas properly. Don't rely on the formula sheet except for the inverse. But the others you must know. So that was 2.3.1. Let's move on to the next one. Alright, 2.3.2. Again, we are dealing with inverse trig functions, but we also have a fraction. You can see that. So when we are dealing with a fraction, we know it's going to be the quotient rule. Okay, that's not a problem. The main thing is to differentiate inverse sine and inverse cos. So if y is equal to inverse sine f of x, then your derivative here is going to be f prime x all divided by the square root of 1 minus f of x all squared. And then if y is equal to inverse cos f of x, then your first derivative, the only difference between inverse sine and inverse cos is going to be minus, that will be f prime x all divided by 1 plus the square root, of 1 minus f of x all squared. The only difference between these two are the signs there. Right, so now let's differentiate. So here I can see that this is a fraction. We have a function of x in the numerator and in the denominator. Okay, so we're going to go dy over dx, quotient rule here. Let's write that down. So your quotient rule is copy the denominator. That is step number 1. Copy the denominator. 1 minus inverse cos of x. Differentiate the numerator. So the derivative of 1 is 0 plus the derivative of inverse sine of x. Now you need to remember now your x is f of x. So the formula is f prime x. That means the derivative of x is 1 all divided by, here's it, all divided by the square root of 1 minus f of x all squared. That's going to be x squared. Right, so that's copy the denominator, differentiate the numerator, minus copy the numerator, 1 plus inverse sine, differentiate the denominator. The derivative of 1 is 0 minus the derivative of inverse cos. There's it right here. It starts with a minus, so that's minus f prime x, which is 1 all over the square root of 1 minus f of x, which is just x there. Can you see that? All squared, and that's it on the top. So remember, we're not done with the quotient rule. Copy the denominator, differentiate the numerator. Minus, copy the numerator, differentiate the denominator, all divided by, this whole thing is divided by the denominator squared. Simplification is not required, so at this point you must get full marks here. But if you wanted to, obviously if you want to, you can go minus minus is plus, but if you leave it, it's still correct. Okay. Let's move on to the next question. Right, next one, 2.4. So how are we going to differentiate this? Now, our base and the exponents, they both have functions of x there. Can you see that? So there is no rule that we have from our table of derivatives that we know of that can just do this in one step. So what do? We need to simplify this first and rewrite it in a form that we can differentiate. So how do we simplify? We're going to introduce logs on both sides. Okay, so now I'm going to introduce, I'm going to go ln of the left hand side. You can go log or ln, but ln is easier to differentiate than log. That's why ln is preferred. So if I go ln on the left, ln on the right hand side. Right, so now, once you introduce ln on both sides, we know now from your logs, you can bring down that exponent. That's going to be sine 2x, and then you got ln of 2x minus e to the power 8x. That's all on the left hand side. We got just ln of y. Now I need to differentiate both sides. Right, so when I differentiate now, y is not the subject of the formula. Can you see that? So when you differentiate, We are differentiating with respect to x, so you will write down. You're going to go, let me just do it. D over dx on the left hand side, d over dx on the right hand side. This is showing now that in the next step, this is what you're going to be doing. Right, so d over dx of ln y. So we use our implicit, this is implicit differentiation. Now, because I need to differentiate y, but I'm differentiating with respect to x, so I'll differentiate ln y as usual. So the derivative of ln y is going to be 1 over y. But what do I multiply by? I need to multiply this by dy over dx. That is implicit differentiation. Now here, on the right hand side, we have sine 2x and we got ln of a function. These are completely different functions and they're being there's no plus, no minus, no subtraction. So this is multiplication. Can you see that? So this will be the product rule. If it's multiplication, it's a product. And how many times we're using it? You notice in this exam, how many times did we use the formula for ln? Can you see that? We've used it in limits, we've used it there, using it here again. Right, so now the product rule. The product rule, you can go and copy down the formula if you want to. I mean, it's on if you forget, but it's to remember it is simple. You copy down the first term or first factor, you're going to call it. So you copy the first, differentiate the second, plus copy the second, differentiate the first. Right. You can call it U, B, whatever you want to, F, G, it's up to you. The main thing is you copy down the first, differentiate the second. So when you differentiate the second, we are using this is ln f of x, so it's going to be f prime x over f of x. Let me copy down my f of x before I forget it, so that's e to the power minus 8x. And then we differentiate this and write down the answer on the top there. So the derivative of 2x is 2. The derivative of minus e to the power minus x. Okay, so this is that simple differentiation. If you have k e to the power f of x, the derivative is going to be k e to the power f of x times f prime x. That's how we differentiate that. So the derivative here is going to be minus e to the power minus x times the derivative of minus x, which is minus 8x, which is minus 8. Yes. That's positive. Oh, sorry, that's positive there. Positive. I copied it down. So that's a positive, 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 positive. Yeah. So let's write down the first, differentiate the second, plus write down the second, which is ln of 2x minus e to the power 8x, positive 8x there. So write down the second, times differentiate the first. The derivative of sine 2x is cos 2x times the derivative of 2x, which is 2. What else do we need to do? Right, so now, it's not the final answer because dy over dx is not yet the subject. We need to make dy over dx the subject of the formula. So all you're going to do is multiply by y over 1 on the left hand side and on the right hand side, obviously. Y and y will cancel it. So dy over dx is equal to y multiplied by everything that you see here, which is sine 2x times, this is 2 minus 8 e to the power 8x all over 2x minus e to the power 8x plus then that's 2x minus e to the power 8x. That's 2 cos 2x. Nothing more to do here. You do not have to substitute that for y. It's fine as it is. Because we already were given. We already know what y is. Alright, so that was 4 marks. one. Let's deal with the next one. Right, so the next question here, determine dy over dx, 4 marks again. Y is not the subject of the formula, so we differentiate implicitly. So all I'm going to do is, I'm going to go d over dx on the left hand side and d over dx on the right hand side. Right, so the left hand side, what do we have? We have tan of f of x. That's what we have. So we got y is equal to tan of f of x. So we know y prime is going to equal to sec squared of f of x times f prime x. So that is how we differentiate tan. However, f of x is actually equal to a multiple of u times v. There's actually x squared times y to the power of 4 there. Can you see that? That's what f of x contains. So when we differentiate this part here, f prime x, so when I find my f prime x, that means when I differentiate this u times v, it's the product rule. You can see that? So because it's multiplication, it's a product rule. So that's going to be u v prime plus v u prime. Or write down the first, differentiate the second. Write down the second, differentiate the first. So that's the left hand side. The right hand side is simple. I don't need to explain it to you. The main thing is the left hand side. You know what to do. So the derivative of tan is going to be sec squared of x squared times y to the power 4. So this is where I am at the moment. You can see that? Times now f prime x, but f of x is u times v. That means x squared times y to the power 4. So f prime x, I need to use the product rule here. I must open up a bracket. If there's no bracket, it's wrong completely. Right, you must open up a bracket and then you apply your product rule inside there. So the product rule is, copy down the first, which is x squared, differentiate the second. The derivative of y to the power 4 is going to be 4 y to the power 3, and every time you differentiate the variable y, you multiply by dy over dx. Are you clear with that? That's implicit. So write down the first, differentiate the second, plus write down the second, which is y to the power 4, and differentiate the first. The derivative of x squared is 2x, and we're done. That is the product rule on the left hand side. Right hand side. The derivative of 3x is 3. The derivative of y squared is 2y. We differentiated the variable y with respect to x. So we're going to multiply by dy over dx. That's a main step. That's a main thing. Now, all you need to do is make dy over dx the subject of the formula. So what am I going to do now? I notice there's dy dx here, dy dx on the left. Let me remove these brackets. So my aim now is to remove brackets and take my common dy over dx. That means I'm going to take all the dy over dx's onto one side. So now I'm going to go that times term 1, so that's going to be 4x squared y cubed dy over dx times sec squared of x squared y to the power 4. So I multiply there, and then that times that will be plus 2x y to the power 4 sec squared of x squared y to the power 4 is equal to 3 plus 2y times my dy over dx. So there's my dy over dx. Right, now it's just manipulating a formula, nothing difficult here. Doing the main thing is, did you know what's happening over here? Right, now all I'm going to do is take my dy over dx to the left hand side. So I got my 4x squared y cubed dy over dx times x squared y to the power 4 minus 2y my d times dy over dx. So I've got all my dy over dx's. There's only two, but on the left hand side, any term that does not have dy over dx, transpose it to the right hand side. So on the right hand side, I got 3 minus 2xy to the power 4 times x squared of x squared y to the power 4. So now what will I do? The whole idea was to take out a common factor of dy over dx. So if I take out dy over dx as a common factor, what am I left with now? Here I got 4x squared y cubed times x squared of x squared y to the power 4 minus 2y. On the left hand side, on the right hand side, I just have 3 minus 2x y to the power 4 sec squared of x squared y to the power 4. And then finally, just divide, and then we're done. So I have 3 minus 2x y to the power 4 sec squared x squared y to the power 4 all divided by 4x squared y cubed times sec squared of x squared y to the power 4. It just takes too long to do this manipulating, but the main thing is, did you recognize your formula that needs to be used and the product rule?